The future of submarine warfare is here. The USS Virginia. Tricked out with high-tech capabilities that allow it to sneak up to a coastline and secretly watch and listen to potential enemies, ready to respond with unwavering force. This mega sub is in a class of its own. The all-new Virginia class.
This is an amazing ship.
Named the USS Virginia as the first of a new class, this amazing sub has staggering capabilities. It's the most advanced and versatile submarine in the world.
I mean, we consider this like the Ferrari of the subclass.
Its crew are some of the best trained submariners in the US Navy.
We picked up Master 2.
And they have to be, because this is the most complex submarine ever built. It's one heck of a weapon. It can launch attacks on other vessels using devastating torpedoes and can deliver cruise missiles 1,600 kilometers inland with pinpoint accuracy. To escape potential enemies, the USS Virginia can dive to depths of up to 240 meters. But what elevates this new supreme sub to a class by itself is its astonishing spying ability. This sub has been called the ultimate eavesdropper, and for good reason. The Virginia has the most sophisticated sensors ever fitted on an American submarine. It can see and hear better than any US sub ever built. But even with such technology, the Virginia must get in close to potential enemies. And she does. Extremely close. She uses a revolutionary automatic navigation system, which allows the Virginia to inch itself through shallow waters to an exact coordinate.
The question for a Virginia is how slow can you go? How well can you take that 8,000-ton submarine and control it in coastal waters a couple feet off the bottom? Can you move that ship inch by inch?
Like a stealth fighter, it has the ability to remain undetected. But unlike the Stealth, the Virginia can stay motionless underwater for up to 3 months if needed.
And we could be sitting there for days and weeks and years, and you'd never know we were there.
This is a sub like no other. With such covert potential, the Virginia's intelligence gathering is second to none. It can also deploy elite forces like Navy SEALs at a moment's notice. Such adaptability makes this sub one of a kind. And the USS Virginia is one heavy sea creature. At 7,100 tons, it weighs as much as 1,600 killer whales. This monster sub is 115 meters from stern to bow. If you were to lay the Statue of Liberty down next to it, the Virginia would still outstretch it by 22 meters. But how does such a beast move so effortlessly underwater? The dynamic thrust of this megastructure is a nuclear reactor. The design and operation of the reactor is top secret. But what we do know is that it's an astonishing powerhouse. A compact nuclear reactor converts seawater to steam. The supercharged steam then spins the massive turbines, which in turn propel the sub. The reactor also powers all electrical needs for this high-tech super sub. And what's more, the nuclear reactor on the Virginia has a 30-year lifespan. Translation, it can go that long without ever needing to be refueled. That's twice the average lifespan of nuclear reactors on other US attack submarines. Today, the USS Virginia is an amazing success story. But a decade earlier, its future and that of the entire United States Submarine Corps was looking bleak. There are two main types of subs in the US Navy fleet. The first are deep ocean ballistic submarines. These have a single strategic mission to carry nuclear missiles, which can be launched at targets anywhere in the world. The other type is the attack submarine. These are designed to move fast, sink vessels, launch cruise missiles, and gather intelligence. Before Virginia, the state-of-the-art in attack submarine design was the Seawolf class. The cost to design and build the first Seawolf submarine was over $5 billion US. It was developed during the Cold War for potential deep ocean battles against the mighty Soviet Navy. But in the early 90s, the political climate dramatically changes. Almost overnight, the Soviet Union collapses. America's archenemy has simply disappeared. The costly arms race between the superpowers is no longer relevant. In this brave new world, it's inevitable that defense budgets are slashed. Every division of the military is a target for cuts. Submarines like the Seawolf class are simply no longer needed. But as the 1990s develop, new enemies of the United States and her allies emerge. Small terrorist groups in tyrannical countries like Iraq and Somalia cause the military to rethink spending.
If you look at the threats we're dealing with today, a lot of the threats are coming from third world countries, small countries, where we need to take the battle, if you will, to them and prepare a battle space around their coastlines.
What is the point of a huge navy if these terrorist armies have no sea power? Why does the US Navy need a submarine at all? Good question. And one that was being discussed at the highest levels in the early 90s. In today's complex world, the military needs to be ever more informed of enemy activity. But US defense already has sophisticated spy planes and satellites. They can see every detail from several kilometers high. They also have better ground reconnaissance and a superior spy system. So what can a submarine offer? In fact, submarines have a lot to offer. The Navy is aware that if they can harness new but unproven technologies, the submarine could remain in shallow waters completely undetected. And what's more, the super spy could stay there for weeks, even months. If a new mega sub can listen and stay close to enemy lines, it can still be an important military asset. In 1995, the US House and Senate finally agreed on the Navy's plan for a new class of attack submarine. But the Navy has set strict guidelines for the submarine designers. The new class of sub must have awesome spy capabilities. She must negotiate shallow waters with pinpoint accuracy. There, she must remain motionless for days on end, regardless of currents and sea drag. She must be able to deploy high-tech weapons to raid on an enemy whenever needed. And she must also be able to dispatch elite special forces like Navy SEALs. The new super sub must have stealth-like maneuverability and be able to disappear underwater for up to 3 months at a time. It's a tall order by any standards, but there's a catch. They have 1 year less than it took to build the first Seawolf. And incredibly, there's an even bigger catch. It has to be made for 20% less money. With such constraints, there were many in the submarine industry who thought it was simply impossible.
I think the reaction is always one of how can we do that? We've never done it before.
If the Navy can make this work, it'll provide a major new weapon in the US arsenal. But if they fail, all US subs could be in question. It's 1996. The US government needs to get up close and personal with new terrorist enemies. The Navy insists that submarines can still help in this thorny urban war. They claim they can build a new class of submarine. Bigger, better, quieter, and more deadly. But there's a catch, a big one. It must be built in less time and for a great deal less money than the previous attack submarine, the Seawolf class. With such limitations, this project looks more likely to sink than float. the Navy decides to offer the mammoth design challenge to a trusted company, Electric Boat. Based in Groton, Connecticut, this company has enjoyed bragging rights that span over a century of ship and submarine building for the U.S. Navy. The first sub they built was the USS Holland for the Navy in 1900. The USS Holland revolutionized the U.S. Navy. It marks the beginning of more than a century of military submarine building. Electric Boat's expertise is second to none, but some government officials already fear that this massive challenge may simply be impossible. Despite the huge red flag, Electric Boat finally agrees to design and develop the new Virginia class. But to bring it in more cheaply than the Seawolf, they'll have to completely change the way submarines are built. It starts with paper and wood. In the past, they would have drawn up initial plans on paper.
Previous classes of submarines were designed historically like probably any other large construction project with two-dimensional drawings, blueprints.
But the problem with two-dimensional plans is that the different designers can't always view each other's layouts. If two engineers from different departments end up competing for the same space, it could lead to lengthy and costly delays. On this tight schedule and budget, there's no room for such error. It'll put the project behind schedule even before it started. It could tip the balance and mean the end of the new super sub. The team needs another solution. They turn to new computer-aided technology. The benefit being that the whole model can be seen in 3 dimensions. This will mean that each department can quickly see what the other is doing. If it works, it'll save the company a fortune and help design a more efficient sub. But if it doesn't work, it could mean the new super sub is doomed from the start. The president of Electric Boat finally decides to take the risk.
He came in and finally took all the drafting boards out of the plant and said, okay, go for it on your computers.
Before the Virginia class, when a submarine was designed on paper, builders would then construct a life-sized wood mock-up of the plans just to make sure everything fit. But with the computer-aided design of the Virginia, that step could be skipped. All of the test fitting could be done right there on the screen. It is the first time that a U.S. Navy submarine is completely designed via computer. And the program that would make this computer-aided design possible is already proven technology. Known as the CATIA program, it has effectively been used in the development of airplanes by the Boeing Corporation. Electric Boat figures there are enough similarities between a plane's fuselage and a submarine to take the plunge. It proves to be the right decision. All the various designers have access to the computer 3D model. This allows engineers to work in the same virtual space at the same time. Designers can now view all the plans to make sure they don't interfere with other layouts.
The piping designer is running his pipes and I'm running my cables. We can go in and detect interferences day by day.
Every part of the ship is scrutinized for function and economy. So creating the sub on a computer seems to allow for the more efficient test fitting of systems and parts. But the next challenge facing designers is figuring out how to create spaces for people. Workers need room to do installations, and sailors need space to do their jobs. So in order to ensure those spaces are adequate, designers welcome the help of this guy. Meet ErgoMan. ErgoMan is a computer-generated image of a human being that comes in 3 virtual sizes: 1.7 meters, 1.8 meters, and 1.9 meters. Whatever movements a human can do, ErgoMan can replicate. Then when the ergonomically correct envelope has been pushed and movement is made that is not humanly possible, ErgoMan clearly lets engineers know by simply turning that body part red, enabling the designer to adjust the space he's working on. This revolutionary technology could save the company millions in costly redesign. It could also guarantee that the crew will operate at maximum efficiency. The computer-aided design also helps in one other crucial way. The future of warfare is uncertain. To meet that uncertainty, this incredible sub must be able to adapt to new situations. As modern warfare changes, so the Virginia must adapt to meet it head-on. To create this adaptability, the designers of this super sub create what's called a modular design that incorporates an open system architecture, meaning the skeletal structure of the sub includes large open spaces. These open spaces can house prefabricated modules such as weapon systems or sonar technologies. These modules can easily be inserted as one complete unit. This modularity will allow future versions of the Virginia class to house newly developed systems in the existing Virginia class layout, without the added expense of having to develop an entirely new class of submarine to house new technologies and capabilities. A remarkable cost-cutting development in the design of a submarine. If it works, this will be the most extraordinary submarine commanding the world's oceans. But designing it is just one problem. Making this ambition a reality is quite another. With an even tighter budget than past submarines, this is going to be a massive challenge to execute. And now there's a new problem. Having spent millions on the design, the Navy may not have enough money left to build it. It looks like the prototype of the new Virginia class may never surface. The Navy is underwriting an enormous new project to build a new class of submarine that will be more versatile than any ever built. But it has to be constructed in less time and for less money than the previous attack submarine, the Seawolf. The design and development have been skillfully and successfully carried out by Electric Boat. And for the first time, a US Navy submarine is completely designed via computer. It's a massive achievement, but there's a problem. The Navy's budget for the Virginia program is running out. It could lead to the end of the new super sub before it's even floated. But then Electric Boat does something unprecedented in its history. For years, Electric Boat has been in competition with Northrop Grumman's Newport News, another heavy hitter in the shipbuilding industry. Now Electric Boat proposes that they combine forces with their old rivals and do something that's never been done before. Build the submarine together, a process they call teaming. They figure that combining resources and brain power will allow them to work more quickly and more efficiently. The proposed alliance can lead to massive savings, $700 million off the cost. But can these two historic adversaries put aside their differences and build a super sub for a reduced price? How can they manage such a massive project across two companies? As we've said, it's never been done before. But the Allied companies must make it work. They have little choice as the Navy has no more money to offer. Making a super sub for less money and in less time than previous attack subs will only be possible if the two rivals collaborate. It's a colossal and dangerous undertaking. If they get it wrong, it could spell the end of the US submarine program. This is a time when the Navy must prove a submarine's worth in a changing world. The two-company alliance agrees that the only way to meet such demands is that there can be no delays. A major setback could erase any cost savings. But such efficiency in submarine construction is unprecedented. Is this project simply too ambitious? Could it be destined for the deep? In 1998, construction finally begins. Like all submarine building, it begins with the most crucial component, the hull. This is where the crew and weapons are housed. If it's not strong enough, the lives of hundreds of men are at stake, as is the multi-billion-dollar submarine. Not just a costly mistake, it would be a national catastrophe. Consequently, the hull for this sub isn't just made out of simple steel. It must resist unbelievable pressure. The Virginia class needs to reach depths up to 240 meters. Here, it's difficult for an enemy to find them. It'll give the submarine maximum safety from attack or detection. But at these depths, there's immense pressure. The steel hull must withstand a massive 26 kilograms of force per square centimeter. That's the equivalent of a dinner plate strong enough to hold up to the weight of an elephant. Getting the steel strong enough to endure such pressure is crucial. The manufacturing of this special metal is a military secret, but suffice to say, it's strong. Extremely strong. But now the problem is how to bend such heavy-duty steel. They use a machine that supplies up to 4,500 tons of pressure. That's over 30 times the pressure exerted by this car-crushing machine. The massive drum shapes and bends the huge plates of steel. Once bent into shape, the steel is mounted onto rib-like frames. It's then welded together into cylinders. This is a critical moment. In the past, this was done by teams of hand welders. But such are the stresses on a deep ocean submarine that even one bad weld could lead to disaster. There's only one answer: robots. These assembly robots can work round the clock and rarely make mistakes.
The weldments that go in out here are better than 99% first-time yield, which means the inspection process is less than 1% failure rate.
It's a costly business, but this is something that can't afford to fail at any price. To make sure the welds are perfect, they're inspected by X-ray. Any imperfections, such as an air bubble in the weld seam, could be just enough for the hull to weaken. It could then give way to the crushing forces exerted deep below the surface. If the X-ray machine shows up any imperfection, it's meticulously repaired. Amazingly, once the seam is perfect, the welds can create a bond that is actually stronger than the original steel. A comforting fact when you're 240 meters below sea level. Once the separate sections of the hull have been created, they start to construct the skeleton. Here in steel processing, they'll make floors, walls, and all the sections that comprise the submarine's framework. Again, robotic manufacturing reduces mistakes and speeds up the process. This is crucial when the alliance companies are desperate to cut costs and time.
Today, modern technology, we're working with electronic data, comes right over the line, feeds the machines. It's incredible.
This incredible laser marker is one of a new generation of robotic assembly. This tool is designed to eliminate human error. It's programmed to follow the computer design with better than pinpoint accuracy.
Basically, it's the only marker of its kind in the free world that we're aware of.
But will this new technology work? It's never been used in submarine construction. The machine passes quality control with flying colors. It's just one of many innovations in building this unique sub. So far, the project is going well. Now the marked steel must be cut. But how do you cut such strong steel? They use a hugely powerful cutting machine known as an abrasive water jet. Here, a constant stream of water acts as the propellant for 80 grit flakes of garnet, which cut through the steel. The advantage to this method of cutting with a cold water propellant is that there is no heat-affected zone, thereby eliminating imperfections caused by expansion, contraction, and melting. Even though garnet is not the hardest abrasive that could be used, it's seen as optimal because it's hard enough to cut without causing too much wear and tear on the water jet's nozzle. The powerful cutting stream strikes the steel with 3,900 kilograms of force per square centimeter. That's strong enough to cut through a 30-centimeter thick piece of steel. Once cut, the sections are ready to be welded into place. This makes up the submarine's skeletal shape. While these sections are being built, other important modular sections are constructed in tandem. Living quarters and weapons are built outside the submarine before final assembly. This allows ease of construction. It can then be rigorously tested before installation. The Virginia's command and control module is the most complex module to be built. It's the brain of the sub. It's where crucial functions are executed and surroundings monitored. It's also where the awesome weapons systems are controlled. If any part of this goes wrong, the whole submarine could be rendered inoperative and end in a voyage to the bottom of the sea. So the Virginia's separate elements, the modular systems, the internal structures, and the outer hull are built with efficiency. But these separate sections have not yet been integrated into a complete submarine. And without a complete submarine, the sailors destined to serve on the Virginia can't set foot onto it and get a feel for its inner workings. Yet they must have a working knowledge of the Virginia's unique operating systems when they're charged with manning the complete submarine. So how do sailors prepare for duty on board this unfinished sub? The Navy would have to get creative to ensure that the human element to this mega sub, the US Navy Submariner, would also be finely tuned for service. This is when the mission could sink or swim. The USS Virginia is a super sub in the making. Nothing like it has ever been built before. So there's no chance of gaining crew experience from other submarines. But the new sub must be fully tested before sea trials. That includes the crew. To operate this new class of submarine will require unique training. But this is a virgin sub, and no one knows all its workings. Like the rest of this project, this too will be a challenge for the Navy to resolve. Training begins with every submariner's nightmare. In mock facilities like this fake engine room, built to simulate a flood. And even though these men are not on an actual sinking sub, this scenario is very real to them. They know that a flood could happen when they're at sea, and the only way to survive it is to stop the water from rushing in.
Flooding in the engine room!
When a sub starts flooding, it becomes a race against possible death for everyone on board.
Flood control has been activated in the engine room. Bombs are manned. Damage control system.
In the heat of battle, the sub can't resurface because the enemy will spot it.
Overflow level TC set for line. This is Andy. You have major rupture in SW discharge.
If too much water gets in, the sub takes on too much weight, permanently ditching itself on the ocean floor. The men cannot escape through the hatch because they're so deep. The water pressure will crush them. If they can't stop the leaks, they will be trapped at the bottom of the ocean, buried alive in an iron coffin.
Hammer.
These sailors are under the close scrutiny of their commanders.
Slow down.
To block small leaks in pipes, the sailors hold plugs in place with rope they call bandit twine. For larger leaks, the sailors patch the holes with rounded metal plates called strongbacks, which are secured with metal straps simply called bandits.
Don't take it apart. Don't take it apart. Tie it up.
Commanders expect the sailors to keep their cool and keep their focus. Fortunately, after a rigorous and stressful series of tests, these sailors get the thumbs up from their commanders. These are good men to be spending months on end with, and that's what a sub is all about. Living in cramped conditions and still functioning well in the face of danger. This is no place for claustrophobics. Every sailor that's on board the USS Virginia, as well as any Navy sub, whether they are the commanding officer or the cook, must know how to mitigate against leaks so that all hands can be helpful should such an emergency arise. But submariners must do more than train for emergency situations. They must also train to do the specific jobs that they're assigned to, such as steering or sonar operations. This requires a familiarity with the sub's operating systems. Sonar and navigation have traditionally been kept separate due to noise factors. Using new technology and space-saving design, these two disciplines have been brought into one central command post for the very first time.
When we first started, it was overwhelming because traditionally, the fleet returning sonarmen that came to the Virginia had a mindset of the way things used to be, where we were in a room separate from everyone. We could set up the sounds that we needed to hear in our room and no one else was distracted by them.
But before sea trials begin, the specialist crew must get familiar with working together. With little alternative, the Navy agrees to invest in building a simulator. Every detail of this high-tech simulator is a functioning replica of the future sub's control room.
This is a very unique trainer. It's specifically for the Virginia class.
Passing 060 to the right, to more course.
For the first time, the crew get their hands on the same controls as the new super subs.
We were confident that the ship was going to act very similar to the trainer as far as motion, but the procedures and everything that we train on over here are identical to the ship.
All back to thirds.
Pilot sonar, no longer hold air.
One thing sonar operators on the new sub will have to get used to is working alongside their colleagues. Sonar has always been monitored in separate rooms to avoid noise interference.
Starboard.
But sonar operators destined for the Virginia must get used to working in the new shared space of the control room.
Pilot sonar, no longer hold air, escaping from the aft main ballast tank.
After initial reservations, the sonar team begin to see the benefits of working with other engineers.
I think overall, in the big picture, it's a benefit. It gives me, as a sonar supervisor, a larger tactical picture of what the boat is doing.
Here in the simulator, operators will get their first experience of a revolutionary innovation. For the very first time, a US submarine is being built without a periscope. Normally, a periscope extends up to the sea's surface. Using a system of mirrors, it allows one person to scan the horizon. But the ultimate eavesdropper needs to be much more aware of her surroundings. Instead of a periscope, she has a mast with multi-sensors and cameras that enable images from all sides. These sensors, known as photonics, are wired to various monitors in the control room. For the first time in submarine history, everyone in the control room monitors surface activity. And because they're all in the same room, communication is much more responsive.
Control, and I'll brief them that we've gained an enemy warship.
While the crew is being put through their paces, construction of this super sub nears its end. The separate hull sections are outfitted with the internal elements they'll house. And then they're pieced together section by section until a full-length submarine finally emerges. By August 2003, the USS Virginia is ready for the water. Against all odds, the alliance companies have done it. They've built an extraordinary new submarine, more technologically advanced than any in the world. It's an amazing achievement. Right now, any celebration could prove to be premature. Unless they get the next and most important phase right, the whole project could become an expensive flop. Virginia must now endure extensive sea trials. The super sub has to prove itself where it really counts, in the ocean. Often in the past, testing new subs has uncovered countless problems. These have proven to be time-consuming and extremely costly. The USS Virginia has been built using revolutionary methods. Time and vast quantities of money have been shaved off the budget. But if this new super sub is to succeed, there can be no slip-ups during trials. It'll knock the whole project off course. The construction of the all-new USS Virginia is at last complete. It's taken 6 years and has cost the Navy billions of dollars to build. But it's still less time and money than its predecessor, the Seawolf. It's a mammoth achievement, but by itself, it's meaningless. The real test lies ahead. If there are errors now, the huge investment could sink to the depths. It could take years to fix any problems that surface and likely put the project beyond economic sense. It could even spell disaster for the whole submarine division. In the past, problems have been common at this stage, but this project simply can't afford to fail. It's now do or die for the new Virginia class. August 2003. The USS Virginia is finally launched. Over the next several months, they will put the sub through extensive tests, known as alpha trials. This is when things can, and often do, go wrong. Previously, subs would factor in time for repairs, but in this new economic climate, the Navy and the Alliance simply don't have that luxury. The Virginia must ace the test.
Historically, the first ships of a class wind up with significant problems.
As the USS Virginia heads out on her maiden voyage, the captain and crew will begin testing all her major functions. All the sub's technology must be tested. They start with sonar. It is the traditional way a submarine sees, even through murky water. The system is based on transmitting and receiving. The main feature of the system is the sonar sphere, housed in the nose cone. The sphere is lined with hundreds of hydrophones that act as the ears of the sub. They're called passive sensors. Their job is to listen to all sounds coming from outside the sub. A giant baffle protects the sonar sphere from internal noise interference. The sonar sphere also has what's known as active sonar capabilities, which is when the sonar releases noise pulses and gathers a clear picture of the sub's surroundings based on the bounce back of the sound waves. Along with the sphere at the bow, there are 6 side-mounted sonars, 3 on each side. These provide a more complete picture of the submarine's surroundings. There's also sonar that can be released from the back of the sub and towed with a line. This area behind the sub is often referred to as the blind spot and would otherwise be vulnerable to attack. Because the Virginia is built to operate in shallow waters near coastlines, it is likely to encounter minefields set up by enemy forces to keep our Navy ships out of their waters. These mines are typically scattered throughout the water, anchored into position with chains. Because of this danger, the USS Virginia is the first submarine in the fleet to house a chin array, which works in combination with a sail array to provide a better picture of what lies ahead and make it more effective at spotting mines so that they can avoid them or detonate them from a safe distance before running into them. The sonar system passes through the stringent test with flying colors. Another defining characteristic of the Virginia class that makes it highly adapted for these shallow water environments is its precision handling.
Head 1/3.
Just like any submarine, it uses a propulsor to adjust speeds. Rudders and planes are used to steer the ship, and the Virginia, like all submarines, uses buoyancy to go up and down. To go down, air is released from ballast tanks, and seawater flows into the tanks, weighing the submarine down and causing it to sink. To go up, pressurized air is pumped into the ballast tanks, forcing seawater out, making the sub lighter and causing it to rise. Water can also be pumped throughout various trim tanks on the sub to keep it in balance. These various tools are universal to US Navy subs, but what's unique about the Virginia class is that they are all dialed into a central program.
Master deck, we can have 200 feet.
So when we set in the course and we set in the depth, it stays at that depth and at that course until we change it.
If the Virginia were to park itself on the ocean floor, currents and tides would cause it to drift. But the Virginia's automated hovering capabilities allow it to maintain its position near the ocean floor, compensating for currents and tidal forces. The Virginia's unique ability to remain locked into position provides another major innovation. As the sub can remain in a fixed position, it's easy for elite forces like Navy SEALs to swim in and out of the escape hatch. No other US submarine has a more effective way of deploying special forces. No other class of submarine in the fleet has a built-in Navy SEAL staging area. This 9-man lockout trunk allows an entire team of SEALs to exit and enter the sub. Once out, they grab mission-specific supplies from lockers located in the fin-like structure on the top of the submarine, known as the sail. And then they're ready to make their quiet approach to land. And if the Navy SEALs need fire cover, there's more than enough on board. The Virginia comes fully armed. There are 12 rocket launchers for firing Tomahawk cruise missiles. A target up to 1,600 kilometers away can be strategically destroyed. 4 torpedo launch tubes are ready and armed to eliminate any surface threat. But when it needs to, the Virginia can simply disappear. To remain stealthy and avoid detection, the Virginia is designed to maneuver in total silence. The Virginia-class sub has a giant duct around its propulsor for noise reduction. And the entire hull structure is covered with a rubber-type coating designed to make it more hydrodynamic.
It's much like driving in your car at high speed down the highway. If you have the windows rolled down, you can't hear the radio because of all the air noise blowing by you. Much like Virginia, when we're driving fast with all this flow noise, we can't hear from our own sensors. So we want to quiet down the ship as much as possible, make her hydrodynamically smooth so there's not a lot of flow noise so we can hear from our own.
Without the combination of these noise reduction technologies, the Virginia couldn't even hear its own sensors. The sound dampening allows them to hear and know what's out there. After rigorous testing of all the new systems, technologies and crew members, at last the alpha trials are over. To everyone's amazement and utter relief, the USS Virginia has passed the alpha trials with a clean sweep.
And it was great to see it return after alpha trials and understand from the 4-star admiral getting off that ship that it performed flawlessly, that he was very pleased with its design. They came back with a broom on the sail, which to us signifies a clean sweep.
A clean sweep means the ship passes every facet of the test. It is one of many stellar performances.
All the trials that I've accomplished since in command have been a great success. The ship has exceeded its expectations in every trial. This truly is a remarkable design.
Normally, when a nuclear-powered submarine is built, a year of testing and then another year of repairs are built into the schedule. But because the Virginia performed so well during testing, that year of repairs is not necessary.
Everybody pitched in, and it was a tremendous effort. It was a great program to be part of, and I'm most proud of the people that made it happen.
The USS Virginia is hailed a landmark achievement in submarine history. The design and build of the Virginia is so successful, it could be put into service a full year ahead of schedule. The Virginia's readiness for service proves that the computer-aided design approach to creating a new class of submarine is the way to go. And that new technologies, combined with the resources of two rival shipbuilding companies working as a team, can yield an affordable submarine with new capabilities. When parked in shallow waters near coastlines, it can support ground force operations and participate in land-based military activities. New capabilities allow this new class of submarine to be more than a warship built to engage enemy navies in the open ocean. The USS Virginia, the first of the Virginia-class submarines. The conflicts that this new breed of submarine are destined to face over the course of the next few decades are unforeseeable, and many of its missions may never be known because they're likely to be top secret. What is known is that whatever its destiny, the USS Virginia is poised to answer the call of duty.